Hey, it's Norm from Tested.com. I'm so excited to be joined by Jeri Ellsworth, your co-founder of Technical Illusions, and this is your new project, CastAR.
Yeah.
Thanks for coming by.
Well, thank you.
I know you guys just launched your Kickstarter, so it's a big deal. You guys have been working on this for a long time. We saw this at Maker Faire, both New York Maker Faire and Bay Area Maker Faire. This is the prototype you guys had then. I know some people haven't seen it yet, and I want you to just go through what CastAR is and how you developed this prototype.
Okay, so what CastAR is a projected augmented reality system. It's done a little bit different than other augmented reality systems that you might wear that put light directly into your eyes. The way it works is there's two micro projectors that project a very dim image out. And that goes out to a special surface, which is called a retroreflector.
Okay.
So this material is highly directional. So the images that are projected out from the glasses bounce directly back to each user. So you could have this rolled out onto your table or hanging on your wall, and then you can have a stereoscopic 3D display wherever the material is.
And it's very directional, meaning the light goes straight, it bounces right back.
Right back.
So it doesn't matter what angle you're looking at?
No. So if you're looking at a rendered scene, and I'm looking at a rendered scene, we'd both get a unique perspective, and we wouldn't get crosstalk between our two images that are projecting because all of your images coming directly back to you.
And this material, it's something very special. It's like what's used in license plates?
License plates, road signs, and this actual material is used for safety gear. So
It's like you tape onto your jacket and your bicycle or something.
Yeah.
Oh, okay. So you have two of these Pico projectors, and then what else goes on the glasses?
So there's a high-speed hardware-accelerated tracking system that tracks infrared LEDs. So you put these infrared LEDs that are on a plate on the table, and that's your origin. And then there's the hardware in here is tracking those points and helping triangulate the position of your head. So we have sub-millimeter tracking of your head position, so we know the rotation of your head, how far away from the surface you are, how low you are. So it's 6 degrees of freedom.
All right, so there's head tracking technology built in these glasses, and we've seen a lot of head tracking before in virtual reality, other augmented reality systems. That's a make or break thing for these type of this type of technology. So what type of tracking are you using?
So we developed this infrared LED technology that uses cell phone cameras.
Okay.
And then we have a little optics trick in there that allows us to use these very inexpensive cell phone image sensors to track the LEDs at high speed. And then we have sub-millimeter accuracy, so we know exactly where your head position is. It's very critical. Like if you present the user with something incorrect as far as visuals, like if they move their head a couple millimeters and you present them with 6 inches of movement, people get nauseous, they get disoriented. So this, if you move a couple millimeters, this knows you moved a couple millimeters and the computer can represent.
So very subtle movements and not just rotational tracking, it's three-dimensional space.
Yeah, so we're pretty much the only low-cost system out there that allows you to do translation. So you can move side to side, forward, back. We can actually track 2 degrees off the surface, which kind of blew our minds. We didn't even think that it would work that low to this LED tracking.
And that allows you to use the surface on basically a flat plane.
Yeah, you could put your chin almost on the table and still project across and see.
In terms of how fast you're tracking, it's about 120 hertz?
120 hertz. And the projectors are running 120 hertz per eye.
Okay, and so you have projectors, the camera, and then a bunch of electronics.
Yeah.
And that gets sent to a computer, and that plays the game on the table, basically.
Yeah. So pretty much the connections are you have a USB connection that's sending down about 80 bytes of information for your head tracking information, and then you have a digital video up, so a DVI or HDMI coming up that's driving both projectors. And then the electronics on top is splitting that out and sending it to each eye.
So this was a prototype that you guys made basically just in time for Bay Area Maker Faire back in May, but it's not what you are planning to give to the Kickstarter backers at the end of the project. I'm handing this over to Will to actually get a little demo of this, but you have some new hardware that you want to show off, and this is what your target is going to be.
Yeah, this is our target model, and actually there's electronics that goes along with this to demonstrate the size of the projection engine. So the projection engine that we had on the other prototypes there was this size. And so that was a standard def projection engine, had solid glass optics through it, very heavy actually and very large.
Yeah, much bigger
so now,
than that target.
We've been working with 3M and some other companies out there to put together a projection engine that's very, very small
Okay.
So this is an HD projector. It's 720p. So there'll be one of these in each of the micro projectors. And then as far as the electronics, the prototypes that he's playing with right now have about 6 chips and a big control box that drive everything. We've shrunk everything down to 2 chips. So there's one receiving the video, there's one that's doing the head tracking and driving the displays. And for production, we're going to shrink this even more. We're going to take the video receiver chip and we're going to put it right into a single chip, convert it to a low power metallized gate array, so we can cut the power way down, and so it can work with cell phones.
And it'll use less power, and it can hide behind the bridge or something.
Exactly. There'll be an image sensor right here, and then right behind that will be the tracking image sensor, the tracking chip, and then there'll be some flex circuits that go off to the micro displays. And that's pretty much the entire set of glasses.
And then these are shutter glasses too.
Yeah, but we're driving them in a quite different way than the flicker glasses that you see for TVs. We're actually running both eyes at 120 hertz, and we're opening the shutters for 50% of the time. And the reason we need to have the shutters is the retroreflector is very directional, but there's still a little bit of crosstalk between the eyes. So we control that crosstalk by just opening the shutters for 50% of the time.
So when you say crosstalk, you're talking about images overlapping.
Yeah, and you don't want to see your left and right eye presented.
And you're compensating that both by the way you're using the shutter glasses and also because of the very directional reflectivity. So Will, you're playing a game right now, and what is it that you're seeing?
So right now what I'm seeing is basically a game board projected. This is, I think, a Unity demo. Is that right, Jeri?
So this is Angry Bots. This is the supplied Unity demo. It's a top-down kind of
like isometric kind of. So what I'm seeing is basically where I look, there's a screen projected in front of me, and it's anywhere on the screen. And a while ago, Jeri held up that other sample material, and when I looked over there at her, the material, it still pops up over there. So like I'm seeing the same game on Jeri. It's much brighter than it was at Maker Faire in the Bay Area this last May, because I know we were in a really dark room then, and while I wouldn't call it dim, it wasn't. I obviously couldn't have used it in a lighting situation like this. It looks really good here, and I'm seeing basically, if you look at my field of view vertically, it's about 2/3 of the screen, maybe half of the screen right now. But when I look down, I see a different part of the world projected in a different area, so I can kind of peek around corners and stuff like that.
So if you even get down low, you can look way across the horizon. You can look way out into the distance.
All right, so while Will's looking at one sheet of this material, basically you can add as many sheets as you want to expand that canvas.
Exactly. Anywhere there's the retroreflective material becomes a stereoscopic 3D display. So if you wanted to have a giant monitor, you just hang a big poster of this on the wall. Or if you wanted to go completely crazy, you could make a holodeck. The only limitation is that you have to have these tracking markers, these little squares. That's what the tracking camera is tracking. So every about 110 degrees as you swing your head, you need to have another one at least that distance so you can pick it up. If you're going to look up, you need to have one on the ceiling.
And the markers right now, as you've developed them to be portable, is just a plate with the reflective material and 5 of these infrared LEDs.
Yeah, they're very inexpensive infrared LEDs that are modulating out their IDs. You can do a lot of cool things with the markers, so you can uniquely identify them. So you could have different surfaces around the room with these unique IDs on them. The computer will know which surface you're looking at, so you can present totally different information on one. So, for instance, a game idea that I keep trying to push Rick to do is make a zombie game where you have like a poster on one side of the wall and a poster on the other side. And it's like a virtual window to a world outside, and you have zombies trying to crawl in.
It's very Alice in Wonderland.
Yeah, and you know which window you're looking at because of the markers.
Wow. And do you imagine doing a demo where you're going to plaster an entire room full of the material?
I'm sure some people will want to do that.
That's definitely something we want to try out. When Will's looking through the prototype glasses, because they're using the standard depth cameras or projectors, his field of view for what he actually sees is about 45 degrees, right?
Yeah.
And with the HD glasses, you get a wider field of view?
Yes, exactly. So with our projection system, it's straightforward to put different lenses on it for different field of view, and it's a trade-off of how much we want to stretch the pixels versus how much do we want to concentrate the pixels in the center of the eye. So for standard def, 45 degrees felt pretty good. For HD, we're going to go well over 60 degrees. And there's even the option, maybe somewhere down the road, you could put corrective lenses on the projector, like if you wanted the very immersive, you put a really wide.
And so you wouldn't see any of the reflective material, the gray, it'd just be the game image.
Yeah.
Is there an ideal distance that you're supposed to use against the material?
So our aperture is pretty small on the lenses, so you can have a really wide focus range on the projectors. So anywhere between, a couple feet to many yards away, you get a really nice image. So if you did a holodeck, for instance, if you want to go crazy that way, you could have multiple people in there. You could be moving around the room, and the projections would go around each other, and it'd be in focus because there's such a wide range of focus on the glasses.
And in addition to just playing a third-person shooter or something on this reflective material, you guys are developing other types of game models that game developers can work on, and you have hardware to represent that, right?
So we have the Magic Wand, which is a way that you can interact with your 3D graphics and 3D worlds. So it's a wand, as you would imagine. You can reach into the 3D environment, touch pixels out into this world. You can click, drag around the world with it and do these swipe motions or direct your units around.
And the wand just has a camera just like the glasses have a camera.
Exactly.
So it sees the 5 LEDs, sees that tracking plate, the game knows where in space that wand is relative to your head, and then you have, and imagine in the future maybe more wands or
so you can have
objects.
unlimited number of glasses looking at these tracking markers. You can have unlimited number of wands looking at them.
Wow.
And they all have sub-millimeter accuracy, so just the most subtle motions you can pick up with the wand or with the glasses.
I imagine that board game geeks are really excited about this.
Oh, yeah.
Bringing something like Warhammer or even like, Risk to life, and you have some other hardware also to track that stuff.
Yeah, so for the board gamers and other people that want to do kind of 2D tracking on a single plane, we developed this RFID grid. So this is just a small section of it from our prototype, but it has RFID pickup coils all through here in a big grid. And you can use inexpensive paper markers like the ones you put on the bottom of products. You can put it down and you can get centimeter accuracy by measuring the power that the RFID is returning back. And so you put them on the bottom of your miniature, put it onto the surface, you can track it around the surface. And then we've also developed our own RFID bases that are more high-tech. They have GPIO control and a microcontroller, so you can do kind of fun things like you can send messages out to the model and turn LEDs on, or turn a motor on if you wanted to put this on a little remote control car, and you could drive it to a known location on the table and drive it around. It knows not to fall off the table. And then as well as having these GPIO that you can send to, you can put buttons and you can trigger back to the computer, so you can use these as input devices. So a little example here, we have a button that you can push. So you can put it down, push the button, and the computer can read that.
Not only does the game know the orientation and where it is on your board, but it's sending signals back, making it do things, and also pressing buttons.
And then if you need super high precision, like for Warhammer, you can add infrared LEDs to the figurine. And then the same base can drive those infrared LEDs, modulate them in the way that the tracking cameras can pick that up, and then you get the same sub-millimeter accuracy as you move across the surface. So you can instead of bringing out your ruler, the computer can actually show you your distance.
All the distances between them. And this RFID prototype, it's rigid, but you're going to work with flexible material?
So we're doing some experiments now with flex circuit. We need to make sure that it's going to be robust if it gets flexed a lot. So there's two directions we might go. It might be a complete roll-up mat. We're going to have two options. There's going to be a 1 meter by 1 meter, and you can stack them to make like a 1 meter by 2 meter. If the flex circuit doesn't look like it's going to hold up, then we're going to do little tiles that snap together. And so for storage, you just pull it apart, stack the tiles.
Very cool. That's a lot of hardware that you're inventing and developing basically by yourself for this project.
Yeah, originally this started at Valve Software, which is a video game company. And we developed the early concepts of the glasses there and proved that we could do this really cool stereoscopic display. And then we're no longer at Valve. Now we've developed a lot of this stuff, like the hardware tracking, the RFID grid, and then also our new thing that we announced with our Kickstarter is a VR clip-on. So this converts from projected augmented reality to what's considered kind of true augmented reality, where you clip these onto the glasses, and then the projectors go into optics inside. It bounces around a couple times and gets directed back to your eyes.
But because they're also a little bit transparent,
Yeah.
then you can also see the world, and then that's augmenting stuff in the real world.
Yeah, so our plan for VR mode, like if you don't want to do transparent mode, is we'll just have a little shutter that goes over the top and completely blocks out the light. And so for people that are accustomed to these VR type displays, this is a great option that you can use the system without the surface.
And so where are you in terms of the hardware right now, in terms of what's next and what you want to get done by the end of this Kickstarter?
So over the Kickstarter campaign, we're going to show various, like the HD prototypes. We're going to show the wands. We're going to show the VR clip-on, in action. And then after we get our funding, then we're going to go right into manufacturing design. So then 10 months out, we'll be shipping all of these peripherals, fully manufactured, mass production.
So the hardware looks great, but I also want to learn a little bit about the software. And let's bring Rick here, who's the other co-founder of Technical Illusions, to learn about actual game development and what type of games that you guys imagine that people will be able to play.
Yeah.
Okay, so now I'm joined by Rick Johnson, the other half of Technical Illusions. You run all the software stuff, which is a completely different language, literally from the hardware stuff, right? Yeah. So in terms of developing the software to work with the glasses and working with game engines, what did you have to adapt?
The first part we have to do is actually talk to the hardware. And so there's a very low-level SDK that gets you the raw data from the tracking, the raw data from the RFID grid, and things like that. If you have a custom engine, you can certainly use that particular SDK to get your game up and running. We also have a high-level SDK, and in this case, we're using Unity. And so if you have a Unity game, it takes you about 5 minutes to convert it into our space. Most of the time it's just taking a game and figuring out how it scales to the physical world and maybe a rotation and a few other types of parameters. But it's very quick and simple to do.
And that's what Will's playing right now is the modified Unity game that, like you said, just took a couple minutes to adapt it. Are there certain game models that work better with us?
The biggest thing to consider about the game is how the user actually interacts and inputs with the game. You're not going to use a mouse in this environment, so understanding that the joystick may be a little bit different. If you're off to one side, do you rotate the input? We have a magic wand, which is a true 3D input device. So how you move objects and how the user does selections and things like that, that you have to consider for this space. But in terms of the raw games and rendering and displaying visual Caesar, for the most part, it's just standard game development.
So it's more of a challenge in game design and how you're approaching the game design, both from what the user is seeing, but also different modes of interaction.
Right. One of the early things we realized in the space is that AR is a very unique way of presenting data. And so we concentrated very quickly on creating experiences and understanding this and doing experiments of what works, what doesn't work. Does this idea fail? Why does it fail? How we can iterate on it and make it better or make people actually have fun and understanding.
And your job is just to provide the tools so that those designers have everything they need to experiment with those ideas.
Right. Everything we've done inside Unity is to be quick and fast for people to do. There's an object to get the interface going, there's an object for the wand, there's an object for the RFID grid to get the data back in from that. So very quick and to get it up and running.
And Unity is a powerful engine. It works on PCs, it works for consoles, also works for mobile devices too. Is that something you're exploring?
We're currently exploring Android right now just because it's a little more open. The rendering requirements for this space, while we're drawing two eyes, most of the time the GPU isn't 100% utilized for games, so lots of spare time to handle what we're doing for that. There's a little bit of mathematical calculations for the tracking, but trivial compared to everything else that the engine's doing.
And you're not even sending that much data back from your devices, from your glasses or wand.
Right now, the hardware that Jeri developed on the glasses does all of the image processing, and so it breaks it down to just point data. And so currently our packet structure is 72 bytes a frame. So very efficient, doesn't saturate the USB bus. And for mobile devices, no power requirements at all. The micro projectors are very efficient, and so our main goal is that you can just plug in your mobile device and sit down at the table and you're up and running.
I think that's what's getting developers excited, is that it's going to be easy for them to integrate into their models. And Will, how are you feeling right now?
I feel great. So I've been playing for what, maybe 15, 20 minutes, I guess, all told. I mean, I don't feel nauseous first, which is the thing that everybody always asks about VR and AR stuff. But it looks really good, and I'm kind of getting into I've realized that I can stoop down and kind of look around and see what's going on in the world a little more than I expected to. So I think that's pretty neat. The projected surface works really well. I'm also not seeing the focal length issues that I sometimes have when I'm wearing goggles, in that it's difficult for me to focus because I have bad vision. So this is really good because my eyes know to focus on the plane.
And then with the Kickstarter you guys are launching, it's ongoing right now.
Right.
People can pledge to get a package with the glasses, with the wand, and with the reflective material.
We've tried to create several different packages to, this space has so many options to it. So we have a simple pack for people that just want to get into it. More of a programmer pack that has the VR AR attachment and the wand and aspects like that. And then the board gamer pack for people who want to do board games where they have the RFID grid and they can track their Warhammer figures and have the computer just do all the fancy calculations of distances and area of effects and things like that. So you can just concentrate on strategy rather than doing your tape measuring all the time.
Right, and that canvassing material, it's not even that expensive in the long run, right?
In the long run, it's we're seeing the prices being pretty cheap. And so we're not trying to gouge the consumer. So once the Kickstarter's off, we're done and hopefully funded. We'll just have the material up and running on our website, and you can just purchase it directly, or if you find it in some other vendor, it's free for you to do.
Awesome! I can't wait to plaster this entire office with that material and make our own holodecks.
Yeah, holodecks is something we want to definitely try. It'll be fun.
Thank you so much, Rick, and thank you, Jeri, for bringing us CastAR. And this is amazing since we've seen it. It's been only 6 months since we've seen it, and it's already come so far. Board games, augmented reality, virtual reality, it's all coming real.
We're trying to make a very compelling package between the physical world and the virtual world.
Well, great. Well, stay tuned for more from Technical Illusions and CastAR. We'll have more stuff on tested.com. I'm Norm, and we'll see you next time.